An electron configuration tells you how electrons are distributed among the subshells, how they are assigned to subshells. If you want to provide a little bit more detail, you can draw what's called an orbital diagram. This one specifically says how electrons are assigned to the orbitals. Okay, and in an orbital diagram, you use arrows to represent electrons. An electron with a spin of plus 1/2 or spin up would be represented by an up arrow. An electron with a m sub s of negative 1/2 or spin down is shown with a downward pointing arrow. When you construct your orbital diagram, you must make sure you follow Pauli's principle, which means no more than 2 electrons per orbital, and if there's a pair of them in an orbital, one has to be spin up, the other has to be spin down. Okay, so let's look at 1s2, 2s2, 2p4, that electron configuration. Okay, what would be an orbital diagram you can draw for that? So 1s2 means you have 2 electrons in the 1s orbital, so I have one spin up, the other one has to be spin down. Okay, 2s2, 2 electrons in the 2s orbital, so that's one electron spin up, the other electron spin down. And then 2p4, that means 4 electrons in a 2p subshell. Now, anytime you have a partially filled subshell, okay, in this case you'll notice your p can accommodate up to 6, right? But you only have 4 electrons. So you'll find that there's more than one way of assigning electrons to the p subshell, those 4 electrons. In fact, there's 15 different ways you can do this. Here's one way. You can go 1, up, down, that's one way. Okay. Another way would be 2 here and these 2 here. So you can have up, down, so that's just another way. And then another way would be something like you can 1, 2, 3 all spin up, and then the 4th one would be spin down. And so that's another way. Okay, so there are many ways of doing it. Anytime you have partially filled subshell, you'll typically have more than one way of drawing an orbital diagram. Also, an orbital diagram, you don't need to use boxes, so you can just line up set it up like as a row of lines. So 1s, 2s, and then 2p would be 3 orbitals, so you represent it by 3 lines. So you can do it this way. So you can say there's one orbital, a pair of electrons in the 1s, a pair in the 2s, and then you can say 3 with parallel spins in the p subshell, and then a 4th electron spin down in the p subshell. Okay, so this is another way you can draw that orbital diagram. Now, Hund's rule of maximum multiplicity says that you can get the lowest energy assignment of electrons if you fill the sublevels singly first with parallel spins before pairing them up. In other words, if you have a partially filled subshell, okay, remember we said there are going to be more than one way of distributing the electrons of a partially filled subshell. Well, Hund's rule says not all of those ways would correspond to the lowest possible. Some of those ways would actually correspond to a lower energy assignment of electrons, so it will give you a more stable atom. And the one that has the lowest energy is one where you spread them out first. You spread out the electrons first with parallel spins before you pair them up. Okay, so in the case of oxygen, graph state 1s2, 2s2, 2p4. So you have a pair in the 1s, one spin up, one spin down. By the way, there's nothing wrong with drawing it spin down first and then spin up. As long as you don't violate Pauli's principle, it's okay. But the convention is to just start with spin up and then go spin down. It doesn't really matter. And then 2s orbital, you can go one spin up, one spin down. That's 2 electrons. Okay. And the p4, according to Hund's rule, to get the maximum multiplicity, maximum multiplicity simply means you get the maximum number of unpaired electrons. You spread them out with parallel spins before you pair them up. So for these 4 electrons would be distributed this way. Spin up, spin up, spin up, spread them out, and then pair. Okay, that's one way. Okay, so that's one of those 15 ways. It's not actually the only way you can do it. You can, like, the fourth one, for example, you can put that fourth one over here. There's nothing wrong with that. Okay, that's also, this is one, each of these different ways is called a microstate. So this particular microstate is one of those that have maximum multiplicity, the most number of unpaired electrons. Okay, and so you can have the pair over here instead. Or you can flip those spins. You can have spin down. You can have, for example, spin down, spin down, spin down, and then pair up over here. Okay, so that, as long as you have the maximum number of electrons with unpaired, maximum number of unpaired electrons, you have maximum multiplicity. And like I said, the customary way of doing this is to start with electrons spin up first, spread them out, and then uh, put the next electron spin down, start pairing them up after you spread them out.